It's a matter of, like, I just want to know, like, I've already tried this, I've tried solving this one, and I keep getting the wrong answers, and this is how I set it up, like, formula.
Can you see the formula? Just write it out. I'm gonna write this down. 435. Terminal velocity. Okay, so the equation to find anything about the terminal velocity is the velocity is equal to the square root of 2 times your mass times g, that's gravity, all over c, which is a coefficient, times rho, which is the density of whatever you're moving through, in this case air, and a, that's the area of contact. So in this case you have a golf ball. What are the dimensions of the golf ball?
6.5 centimeters.
6.5 centimeters. Is that in the diameter?
That's the diameter.
Who's teacher? Who's your teacher?
0.065
brother
meters.
Turcott.
What else do we know?
We also know the speed, the velocity, which is 30 meters per second.
That's the terminal speed, yeah.
Terminal speed.
And what else do we have?
We have everything else, and it's asking for the mass.
What's c?
I need to look at it. I think it's 0.5. I need to look at it though.
So in the book, so for c, you just look in the book. It'll have a table of different coefficients.
Yeah, they
It's
do.
basically how aerodynamic it is.
So for C is going to have to be, yep, I was right, 0.5.
What's rho?
Rho is 1.2 kilograms per meters cubed.
And we have gravity.
Gravity was 9.8.
And what's the area going to be?
Area is basically pi r squared, so you have to take 0.65 and square that and multiply that times d
Cool.
pi. I mean, I've gotten all that and I still get the wrong answer. Like, I plug all that in. And
So let's solve for m. Your m is equal to v squared times c rho a over 2g.
yes,
Okay. Did you change this to meters?
yes.
Let's try it. Real quick.
Basically, mine, I already have it here, so I don't know if you want to look at it.
Oh yeah, that's great.
It's in my calculator already.
It's because it was spread out. Divided by 4 times 0.065 squared. Divided by 2 times 9.8. I got the mass is 0.091 kilograms.
Oh. Let me see.
With this, the good thing with this calculator is if you put it in and hit enter, it'll show you everything. So it's better to put it all in as one chunk
Mm-hmm.
than do it as separate individuals. Because if you put it in as one chunk, then it shows you the actual fraction,
Okay.
and you can see if there's any errors to it.
So how'd you get the 4 down here?
4, because so that you don't have to change that to d or to r.
Oh, wait.
Pi r squared is the same thing as pi over 4 times d squared.
I see my
Because
error.
D
I forgot
is-
to convert diameters to radius.
Oh.
I was treating that as a radius instead of
Oh,
diameter.
got it, yeah.
So
So that's the terminal velocity.
See if it works.
Okay. 0.091.
So what's our terminal velocity as people?
That was the answer. But
Nice.
it's actually 91 grams, so
Yeah.
Yeah, well,
yeah.
it's exactly, it's like, which one's bigger, 1 foot or 12 inches? It's like, they're the exact same thing.
Yeah. Wow. That was a simple mistake.
At least it's a simple mistake, not
Yeah.
greater than that.
So true. Gotta love terminal velocity, you guys. That's what stops asteroids from coming and hitting Earth and destroying everything. Because otherwise they'd just go straight right through. What causes terminal velocity? Anybody?
Air resistance.
Yeah. So without air resistance, you just keep speeding up and speeding up and never stopping. Like if you were to jump out of an airplane over the moon, you just keep speeding up, going like a couple thousand miles per hour.
So the drag is when you have a parachute on.
Yeah, that helps. That increases this by a lot. Like the parachute will cause this to go from 0.5 to like 20 or something. It's something ridiculously high. So that means that you'd have to be a lot heavier for you to be still going that speed. But since you don't weigh, you wouldn't weigh that much, you would just like cut it all out.
Alright, cool.
Aerodynamics, you guys, it's kind of legit.